When I'm solving a rational inequality, I'm going to use many of the same steps that we did when we solved a polynomial inequality. However, in addition to finding the zeros, because that's where our graphs changed directions before, I'm also going to find the vertical asymptotes, because in rational functions, your graphs may also change directions at vertical asymptotes. So let's start with one that's already been factored for us, and like we've done before, I'm going to make my number line, and I'm going to include my zeros and my vertical asymptotes. Recall that to find the zeros of a rational function, it's whatever makes the top equal to 0. So in this case, my zeros are going to be -2 and +3. Anything that would make the bottom equal to 0 is going to be your vertical asymptote. So my vertical asymptote this time is going to occur when x is 4. So let's go ahead and get those 3 points graphed on my number line. So I'll have a point at -2, that's where my graph may change directions. I'll have a point at 3, and then I'll have a point at 4. And what I'll probably do for 4 is I'm going to actually make a whole big dashed line, like right down my number line, and label that as my vertical asymptote. Because remember, no matter what, your x value can never be equal to that vertical asymptote. So even if your inequality is leading you to believe that it's okay to be equal to 0, remember that plugging in 4 would never ever be okay. Because as soon as I make x 4, I'd be dividing by 0, and that can't happen. So at this point, I'm going to switch over, like we've been doing, to my calculator, and then try to use my table and my graph to determine what intervals are positive or negative or whatever. So let's switch over to a graphing calculator to figure that out so we can finish answering this question. Alright, so now that we have our zeros and our vertical asymptote on our number line, let's go ahead and take a look at the graph and the table to determine the intervals where the graph is above the x-axis or below the x-axis. Keep in mind, if you don't have a newer calculator where you can do fractions, make sure you have a double set of parentheses around the numerator, and make sure your denominator is in parentheses as well. So if I hit graph, here's what I'm seeing. Remember, -2 is where your graph may change directions, +3 is where your graph may change directions, and then there's a vertical asymptote at 4. And so using the graph, I can see that if I pick a number smaller than -2, like if I go over here on the number line, my graph is below me, so there's a negative interval. If I pick a section or pick an interval, pick a number on the interval between -2 and +3, I can see that on that interval the graph is actually above the x-axis, so I've labeled that positive. If I pick a number bigger than 3, that interval is negative. And then finally, on my graph I don't see anything, but if I double check my table, remember sometimes it's a good idea to use your table and use your graph together. If I pick a number bigger than 4, I see that the y value is also positive. It's a number bigger than 4, even though it wasn't on my graph because it was above 10. I can see it's positive. Remember too, I know we've already taken a look at the zeros in the previous part of the video, but remember you can also find zeros by looking at your table. And so right there, when x is 3, there was one of my zeros. If I keep scrolling to -2, there's a 0 as well. So I can find them that way. So anyway, I've determined my intervals where my graph is positive or negative. To finish this problem then, I was asked to determine where this rational function was greater than or equal to 0. In other words, where the graph is positive. Well, between -2 and 3, that interval was positive, and because I could be equal to 0, I used brackets. That equal to bar means brackets are okay. There's also a section where if I'm bigger than 4, I'm also positive. So notice from 4 to infinity is my other interval where the graph is positive, but notice at 4 I used a parenthesis because even though I'm allowed to be equal to 0, plugging in 4 for x is not okay, because if I make x 4, I'd be dividing by 0, and that can't happen. So that's why I said before, make sure you make a big note in your number line about how 4 is actually a vertical asymptote. No matter what, I can't touch that. So there are the two intervals where the graph is positive.